So hello, I'm Miguel here once again with eighth chapter, that is behavioral modeling. So let's get started with it. So firstly, modeling circuit with logic gate and continuous assignment is quite complex. Behavioral model is higher level of abstraction in which model can be defined as its functional behavior. Thus, behavioral constructs are well suited for tracking problems such as describing microprocessor or implementing complex timing checks. Behavior level abstraction. Verilog models contain structured procedural statements that can control the simulation and manipulation of variable of the data types previously described. These statements are contained within procedure. Each procedure has an activity flow associated with it. There are two types of structured procedural construct, initial and always. Behavioral level example, test for example, module test with integer data a and register var. The type of block sensitivity list beginning of the block and multiple statements always procedural block. Behavioral level example of them. Here we have seen behavior module test where we have three integers data A, data B, and results, which are both, which all of them are 32-bit integer data. Then we have an initial block which will begin with data. We have assigned data value as A and data B is equal to 3. And after that we have done operation. We have done a always operation where results is equal to data A plus data B, and we will monitor the output inside of always or in always statement as shown in the figure below. Structured always block. All behaviors inside the always block constitute an always block. The always block starts at zero simulation time and always block continuously executes throughout the entire simulation time. The value of the statement inside the always block depends its trigger signal and timing control. Always block example. The above code will generate a clock signal with 50% duty cycle as always block is start at zero simulation time but wait for 10 time units then and inverse the clock signal. The always block executes this statement continuously. Initial block. All the behavior statements inside an initial block constitute an initial block. All the initial statement starts concurrently at zero simulation time and all the initial block execute its statements only once. Each block finish execution independently to address and multiple statements are enclosed inside the begin and end like C language. Module clock gen. REC clock initial begin clock is equal to this code initial block code. Here as you can see an initial block where clock values are changed after every 10 time interval. The initial block start at G, it executes sequentially in two initial blocks start at 0 seconds but finish at 60 time unit. Then procedural assignment. Procedural assignments are used for updating register integer time memory. There is significant difference between procedural and continuous assignment. Consider try at let variable and evaluate and update them whenever an operand changes its value. While procedural update the value under the control of procedural flow constant that surrounds them. Blocking procedural assignment. Blocking procedural assignment must be executed before the execution of the statement that follows it in a sequential block. The blocking assignment statement that do not prevent the execution of statement and that follows it in a parallel block. Example sum where timing control 10 and data 1 plus data 2. Where L value is a data type that is valid for procedural assignment and is the operational assignment delay. The timing control can either be a delay control, for example 6, or event control, for example at. The expression in the right hand side of value simulates assignment at the left hand side. Non-blocking procedural assignment allows you to schedule assignment without blocking the procedural flow. We can use non-blocking procedural assignment whenever you want to make several register assignments within the same time step without regard to order or dependence from each other. Where L value is a data type that is valued for procedural value, where arrow is not non-blocking assignment operator. Timing control is the operational intra-assignment timing controller. The timing control delay can either be a delay control, for example #6, or event control, for example at progress clock. The expression of the right hand side of the value assigns to the left hand side. Working process for a non-blocking assignment. When the simulator encounters a non-blocking assignment, the simulator evaluates and executes the non-blocking two-step. First, the simulator evaluates the right-hand side and schedules the assignment in a new value to take place at a specific time by a procedural time control. And number two, at the end of each time step, which value delays or expires, a event has takes place, the simulator executes the new response. For example, A equal to B equal to working process. Okay, multiple non-blocking assignments to the same register in a particular time. So multiple non-blocking assigned to same register with time controls. Then evaluating the right hand side of all assignments in the current time slot executes all the blocking procedural assignment. At the same time, all blocking procedural assignments are set aside for processing all non-blocking assignments that have no timing controls, checking for procedures that have timing control, and executing timing control set to the current time unit. Advance the simulation clock conditional statements. Timing control, delay based timing control, intra assignment timing control, inter assignment timing control, zero assignment timing control, event based timing control, uh, regular event timing control, named event timing control, or event or time or control, level sensitive timing control. Delay based timing control. In intra assignment timing control, there is also known as regular assignment timing control. In this type of delay, the assignment gets much of the delay to execute a deal and you tend to execute it. Inter assignment timing delay. One example, as you could see here, where B is equal to will be taken after 10 seconds and then 10% after 25 seconds. C equal to A will be done again 2 at 27 seconds. C is equal to 4 will be done and B will be done at the same time as the last line, that is at 27 seconds. Delay based timing control, intra assignment delay. Intra assignment. This is also a propagation or transport delay. In expression, RSS is stored temporarily to the register and assigned at the later time of the time delay. Zero assignment time delay is the expression that is shown executed at the end of the statement before. Event based timing control. Uh, Event-based timing control allows conditional statement based on occupants of a named event. The Verilog waits for a predefined signal or user-defined variable that changes to execute the block. This is as when the clock changes execute A equal to B. When the clock changes to 0, A equal to B is executed. A is equal to at one clock will immediately when assigned to any positive clock edge. Even name-based event control. Event data and user defined event. When the event is triggered, the event will basically will be run. Event or control. If you wish to execute either of the variable changes with sensitive the list of the triggers, or so we could use a single comma to separate the sensitivity in the variable. Always changes he changes or she changes in the second, if in case if any of the variable causes the execution of the second. Because this is the idea of the event being timing control described in the previous section. Timing control. Level sensitive control. Always at first clock begin wait count is equal to count plus 1. It will wait for a signal count en to make an increment on the count value whenever count en is high. Blocking and non-blocking timing example. Here are some of the example which you could see. And conditional statement, if else statement, syntax is that if conditional expression statement else. As you could see here, we have if select equal to 1, out 1 will be done if order out is equal to I and 2. If else statement, if say as you could see, if 4 is to 1 multiplication using a if else statement and input and output, and we have already specified those. And if any of this will change, always statement will run, and inside of that, if control equal to 1, then if control 2 equal to 1, this will be done, else it will be running. If control 2 equal to 1, then out will be this, else will be this. There. Case statements, like similar to switch cases which is available in many programming languages, we have also similar thing in here where we select a case and an expression, then we have an alternative one. If it is equal to the expression, then statement 1 will be running. Similarly, if alternative 2 is equal to the expression, then statement 2 will be running. And if alternative 3 is equal to the, all of them, none of them are equal to, then the default statement will be executed. As you could see here, we have given the two of them. If that are we have a concatenation of control 2 and control 1, we have passed the case, and if the value is equal to 2b00, then out will be in1, else if b201, then out will be 2. They're similar to that. ALU example using switch case, you could see as it's been done here. The control, if the control is equal to the to d0, then will be basically the divide operation. If it is 1, it will multiply operation. 2, then will use subtraction operation. 3, then subtraction operation. Conditional operator. Conditional is similar to if else statement, but it's a one-liner, so it's much more concise syntax. It might look a bit complicated, but it is pretty useful to use. As you can see in example, if out equal to cell, then if out if cell is true, then out equal to in1, else out equal to in2. Then our looping construct, similar to how loop exists in most programming languages, there is also necessity to have loop in Verilog too. So we have basically four types of loop: while loop, for loop, repeat loop, and forever loop. While loop executes the statements while it's true. For loop executes the statements that can be initialized, test, or increment with it. Repeat loop executes the repeater's fixed interval of time forever, runs the statement forever and until the simulation is halted. Here you can see a simple syntax for while loop, while conditional, and statement. While loop execute while the condition is true, and many multiple statements in the loop can be grouped using the keyword begin end. And while and condition is then we begin in a block with jug equal jug plus then display jug and end. Then comes for loop. For loops are basically with an initializer, a conditional, and an update, which is pretty much common for many of the similar loops in many programming languages. For loop is same as C, ES3 part, for the Katan. We have the module for loops. As you can see, for the initialize an index variable which is equal to 0, then we have given a condition it should be less than 32, and every iteration it will be increased by 1. And inside of this we have a begin end block, inside of which we have data is equal to data plus 5, and we'll be displaying the data. Repeat loop, as we have already told, repeat loop is something where repeat and the loop until unless the basically till we till the count till the till the condition is satisfied, and after that it stops. And then we have forever loop which run on and on until the execution stalls. Then after that we have tasks and functions. Tasks and functions, the ability to a common procedures for several places in the description will also provide a means of breaking a large procedure into small ones to make it easier to read and debug the source description. Input, output, in, out arguments can be passed on the both the task and function. The next sections will describe the difference between tasks and functions, etc. And that's it for now. So we'll be meeting soon for the next module.